All right, boys and girls, welcome back. Today we're going to be doing areas of a parallelogram. I'm sure that you're used to the area of a rectangle, and that area equals length times width. And you can see here that whichever ones you want to call length and the other one you want to call width, it doesn't really matter. The associative property of multiplication means I can switch these around. So you can call this 6 or you can call this 5. It doesn't really matter. We'll call length 6. The width 5, and 6 times 5, you know the area, equals 30. So the area of a parallelogram is a little bit different. Parallelograms are almost like rectangles, except they're basically a rectangle that's kind of been pushed on its side. You can see parallelogram A here. These two are equal. It kind of looks like a rectangle, except it's got a slant to it, to the two ends. But you can see the two ends, they match each other. They're the same length. They're parallel to each other. They go in the same direction. So it is a parallelogram. And the top and the bottom, they're the same length. They're just kind of pushed over. You can see that this one square is farther over than this side. And this square over here is farther over on the top. So, and I wanted to show you that these two are equal. These two parallelograms are equal, but I'm going to do something to them. I'm going to take one parallelogram. You saw they're both equal. I just wanted the other one for reference for you. And I am going to cut. Let me make it easier on myself. I'm going to cut top to bottom one of the sides, and then I can match it up over here, and now it looks more like a traditional rectangle. So now this parallelogram here, that was parallelogram A, didn't look much like a rectangle, kinda. Now, if all I had to do was cut that one side off, now it's a perfect rectangle. Each side is the same. Each side was the same up here too, except they were slanted. And they weren't straight up and down, straight across from each other. But now they are. And now it's pretty easy to see this is two squares, right? So this parallelogram, or this square, or rectangle, sorry, is 2. And then 1, 2, 3, 4, 5, 6 across. So 2 and 6, as you can see, the area is 12. The area is length times width. So this area equals 2 times 6. So the area equals 12 for this rectangle. Well, how would I get that with this? I don't necessarily know what this is. Well, it's almost the same way. On area of a parallelogram, I want you to kind of look at this and see how you get 12 from this, because the answer is also 12. The area is still 12. The area doesn't change. Just because I went like this doesn't mean it changes. So this is 12, and this is 12. How would I get 12 from this? Go ahead and pause and think it out. I'll have a solution for you when you come back. All right, boys and girls, pause again if you need to for the new information. I have taped these down now so that I can work with them a little easier and you can see them better. I also wanted to point out, any of you that figured it out, you could see that there is definitely 6 on this side. 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4, 5, 6. So there's 6 on these sides, just like there were 6 on these sides. And there's 2 on this side and 2 on the opposite side because it's a rectangle. Well, this must be 2 and 2, but you might have seen that the slant makes it difficult to calculate whether or not that's 2 or not. And actually, it would be very difficult to calculate whether it's 2 or not. So instead, what you're going to do is check the height. So how high does this go? Does from one side that's equal to the other? Well, it goes 1, 2 high. So the height here, we'll call this height equals 2. And it's going to show you that the area of a parallelogram is area equals height times base. And this here is a base. Or you could consider this the base. It really doesn't matter. And the height is basically just straight up and down. Now these could be turned, so you're going to see on Con that a lot of the shapes are turned. But basically they're just asking you what the one side times the height is. So it's a base times a height. And the base and the height are always perpendicular. What that means is they make a right angle. So this is a 90-degree angle. It's a right angle. They always make a right angle. So the area of this is 12 again. The height is 2. The base is 6. And that equals 12. The area equals 12. So one more for practice. Like I said, if there's anything here you didn't get down in your notes, please get it down. And we'll come back for practice in just a second. Alright, boys, girls, if you need to pause to copy this, I did try to make this a parallelogram. My drawing's not great, but just try to pretend like these are slanted at the exact same angle. And it's a parallelogram just like you would see up here. I did turn it on its side a bit to make it look a little funky for you, so that you can, you're going to see a lot of those also on Con. So you see 3 different numbers here, and there's an extra number. We don't need one. The slanty side, if you want to call it that, the slanted side is 4. The base is 5. This side would be 5 too. And the height you see here is 3. Now I always like to take the height from the inside. Sometimes you will see them draw up from a corner or down from a corner, a straight up and down line that would be 90 degrees, and they would say that this is 3. But I like to go inside the figure, just me personally, so I don't make a different shape out here. I don't want to get confused. I only want to look at my original shape. So anyway, they're showing me what the height is. They're showing me the right angle. I know that this is the height. It's 3. I only need 3 and the base. This is what's perpendicular. These 2 sides here that are 5. This is kind of wasted information. So it's really the area equals 3 times 5 equals 15 on this one. And we will do one more for practice. On the next one, I am going to take away the height, and you have to figure it out. All right, boys, girls, take a second to copy down this information and think about it. Try to come up with the solution. Pause as long as you need to get the solution. I'm going to continue on in just a second here, so it's really important to pause me whenever you need to. So I have the area of this parallelogram is 20 meters squared. 20 meters squared. Now you're going to see this. I didn't give a unit last time. I didn't want to confuse you too much. I wanted you to think about the concept. But you are going to see, all units or all measurements need a unit. So, if you're measuring in inches or meters or whatever it is. And this one, area is always squared because you're multiplying them together. So it's meters times meters means meters squared. This is going to be meters times meters too. I'm going to call this 5 meters. So you can see that this is 5 meters, and you'd say, well, where's the base? Well, you could consider this the base, but also the opposite side would be 5 meters. This would be the base. So then you say, well, what's missing? I'm going to ask you, what is the height? What is the height? I'll give you a couple hints. You can pause as much as you want. Think about it. If you think you can get it without the hints, I'll give you one hint here. Area equals base times height. The height's missing. Area equals base times height. You know the area is 20. Pause anytime you need to. the base is 5 multiplied times the height. Some of you are starting to see what the height is now. And the height is, of course, 4, because 4 times 5 equals 20. So I know that this is 4 meters. And actually, if this is 4 meters and this is 5 meters, that's a big parallelogram, by the way. This would be 4 meters squared. All right, good luck, boys and girls. I'll be assigning on Con. I will be assigning finding the area of parallelograms and also the height of parallelograms with the area given. All right, good luck.